Hi everyone. In the production technology of agricultural machinery, in Unit 4, Advanced Manufacturing Process, now we discuss about the thermal energy based process. Before that, we now discuss about the principles of thermal energy. Here the machining is done by usage of heat energy. Here the heat energy is focused on a particular portion for melt and vibrate the work material. Some of the examples for the thermal energy. First one, electron beam machining process, EBM. Second one, laser beam machining, LBM. And third one, plasma arc machining. In this slide, we discuss electron beam machining and laser beam machining process. So now we start the electron beam machining process. In electron beam machining process, high velocity focused beam of electrons are used to remove the metal from the workpiece. These electrons are traveling at half the velocity of light, that is 1.6 into 10 power 8 meter per second. This process is best suited for micro cutting of materials. This is the image of the electron beam machining, that is arrangements of electron beam machining. Now we discuss about the principle of electron beam machining. Here, when the high velocity beam of electrons strike the workpiece, its kinetic energy is converted into heat. This concentrated heat rises the temperature of workpiece's material and vibrates a small amount of it, resulting in removal of material from the workpieces. This is the principle of electron beam machining. Here now we discuss about the types of beam. So first one, machining inside the vacuum chamber, and one more type, machining outside the vacuum chamber. Characteristics of EBM process: accelerating voltage 50 to 200 kilovolt, beam current 100 to 1000 microamps, electron velocity 1.6 into 10 power 8 meter per second, power density 6500 billion watt per millimeter square, medium vacuum, that is 10 power minus 5 to 10 power minus 6 millimeter of mercury, workpiece material, all type of materials machined, depth of cut up to 6.5 mm we measured, and material removal rate up to 40 millimeter cube per second, and specific power consumptions 0.5 to 50 kilowatt. These are all the properties of the electron beam machining process. Next, advantages of electron beam machining process. So this electron machining process is an excellent process for microfinishing. Also very small holes can be machined, and holes of different sizes and shapes can be machined using electron beam machining process. There is no mechanical contact between tool and work pieces, and it is a very quicker process. Harder materials can also be machined at a faster rate than conventional machining. Electrical conductor materials can be also machined using EBM process. The physical and metallurgical damage to the workpieces are very less, and this process can be easily automated. Extremely close tolerance are obtained. Brittle and fragile materials can be machined using EBM process. Some of the limitations of the EBM process are: the metal removal rate is very slow, cost of equipment is very high, it is not suitable for large workpieces, high skilled operators are required to operate this machine, high specific energy consumption, a little taper produced on holes, and vacuum requirements limits the size of the workpiece. It is applicable only for thin materials only. all the spot where the electron beam strike the material. So a small amount of recasting and metal splash can occur on the surface of the metal. So it has to be removed afterwards by abrasive cleaning. It is not suitable for producing perfectly cylindrical deep holes. Now we discuss about the process parameter of EBM. First one, control of current. Second one, control of spot diameter. And third one, control of focal distance of magnetic lens. Process parameters. So first one, control of current. Here, the heated tungsten filament cathode emits electrons depending upon the thermonic emissions capability of the filament. This is based on the filament. It is given by Rizard-Desman equations. Here, J equal to AT squared e power minus K power e power W E into W divided by KT. Then second process parameters, control of spot diameter. Here, the diameter of this spot depends upon beam current, accelerating voltage, magnetic lens, distance between gun and workpieces, etc. The most important three factors which contribute to change in spot diameter are given below. So first one, effect of thermal velocities, and second one, spherical deviations of the focusing lens, and third one, space charge spreading of target. Next, third parameters, control of focal distance of magnetic lens. Here the focal distance at magnetic lens is given by F divided by S plus T equal to 25 V divided by NTV whole square. Here V equal to electron accelerating voltage and NT ampere turns in the lens winding. Next one, next we now discuss about the laser beam machining. Laser means light amplification by stimulated emission of radiations. It produces a powerful and also monogrammatic and collimated beam of light in which the waves are co-current. These are some history about the lasers. The laser difference between normal light waves and laser waves. Here the normal light waves, multiple wavelength, it is diverged, that is not parallel, dispersed, that is multi-directional view. In laser waves, monogrammatic, that is wavelength is equal and same, and collimated, that is parallel and also not diverging, and co-current, that is unidirectional. This is the difference between normal light waves and laser waves. Next one, principle of laser beam productions. Lasers works on the principle of quantum theory of radiations. So consider now an atom in the ground state, that is lower energy E1. When the light radiations falls on the atom, it absorbs a photon of energy HV and goes to the excited state E2. Now here before absorption and after absorption shown in the figures. Normally the atoms in the excited state will not stay there for a long time. It comes to the ground state by emitting a photon of energy E equal to HV. Accuracy, like the electron beam, the laser beam is also used for drilling micro holes up to 25 micrometer and for the cutting very narrow slots with dimensional accuracy plus or minus 0.025 mm. Different types of lasers. First one, gas laser. Second one, solid lasers. And third one, liquid lasers. And fourth one, semiconductor lasers. There is solid laser, ruby laser. Generally, we use synthetic ruby rod. It is made up of crystal of aluminum oxide. This is the arrangements of the laser beam machinings. Here in this arrangement schematic diagram of LBM, laser beam machining, here the reflecting end, this is the flash tube, this is the ruby crystal rod, and here the partially reflected end, and this is the laser beams. Few chromium atoms are placed in ruby rod for absorbing green light. Here we use 250 to 1000 watts power. Flash tube is filled with xenon, argon, or krypton gases. Here the workpiece is arranged in below the laser beam. Cooling of ruby rod is necessary because they are less efficient in high temperature. This is the ruby lasers. Monogamic coherent light emitted from these ruby lasers. Next one, solid state laser. Ruby laser, then neodymium doped atium aluminum carbonate laser and the neodymium doped glass laser are examples of solid state lasers. These mostly used solid state lasers is ruby laser. Gas laser, the main advantages of gas laser is it can be operated continuously. The gas laser produces exponentially a high monochromatically and high stability of frequency. The output of the laser can be changed to a certain available wavelength, so the gas lasers are widely used in industries. Next one, semiconductor laser. Lasing action can also be produced in semiconductors. The most compact type of laser is semiconductor laser. It is also known as the injection laser. In simplest form, the diode laser consists of a PN junctions doped in a single crystal of a suitable semiconductor. These are all the machining applications of lasers. Lasers is applicable in metal cutting, drilling, welding, surface treatment, trimming, planking, and also micro machining process is used. These are all the images for the laser in metal cutting. This is the arrangements of the laser in metal cutting and some of the machining examples of the laser in metal cutting. Now laser is used in the drilling process and laser is used in the surface treatment process. A thin layer of cobalt alloy coating is applied on turbine blade for heat and wear resistance. A thin ceramic coating is applied on metal surface for heat and wear resistance. It is also used to seal the micro cracks which are usually present in the hard chromium electroplates. Advantages of LBM. All kind of metals are machined. Micro holes are possible. Soft materials like rubber can be machined. No tool and contact with workpieces. It is automated process and controlling of beam is easy. Next, disadvantages of laser beam machining process. It is a high initial cost. Operating cost is high. Required skilled labors. Rate of production is low and need safety equipments. Life of flash lamp is low and the machined holes are not straight and also not round. These are all the disadvantages of laser beam machining process. That's all. Thank you.